In this video, we're going to talk about ionic compound nomenclature, the Zumdahl type 2. Now, in the type 2, these are when we have cations that can form more than one possible charge. Usually we're talking about our transition elements. And we're going to start off talking about the binary compounds, where we only have two elements. Now, the rules are very similar to our type 1 Zumdahl nomenclature. And so we take the naming of the cation first and the anion second. The cation is the metal name, and the anion takes the root of the nonmetal and adds the IDE suffix. Now, the only difference is we need to be able to specify the charge of the cation. So we give the compound a middle name. The charge of the cation is given in parentheses as a Roman numeral. Now, this means you cannot look at the periodic table and determine what that cation charge is going to be. You need the anion charge to determine the cation charge. It is the only way. So, as a reminder, for our monatomic anions, group 7A are -1, group 6A are -2, and group 5A are -3. And just to make sure we remember these guys, for the polyatomics, we need to memorize the name, the formula, and the charge. So let's do a demonstration of a few of the formula to name in this type 2 nomenclature. So let's start off with our manganese and our chlorine here. So in order to determine the charge on that cation, I need to know the charge on the anion. So everything starts out the same as normal. So we take and name the element first as the element name, manganese, and then this is a manganese chloride. Now, that cation charge, the chlorine takes on a -1. There are two -1s. So since there are two -1s, the cation charge, this must be the manganese 2+ ion. So we write in Roman numerals in parentheses 2. So this is manganese 2 chloride. So let's take a look at the next one. Here we have another manganese chloride. So we're going to go ahead and just write manganese chloride. And in this case, we have 3 of the -1. So 3 times the -1. That means that this manganese must be the manganese 3+ ion. So this must be manganese 3 chloride. If we move on to our next compound, we have the manganese with an oxygen. So we would write this out as being a manganese oxide. Manganese oxide. But what is the charge on the manganese? The oxide anion takes a 2 negative charge. So I've got 2 times a -2. That's a -4 total charge. Now, since I've only got one manganese, that means that must be providing a total of +4 charge. So this would be manganese 4 oxide. Now, this is probably the most problematic one here, but it's actually pretty simple. So, I know I have another manganese oxide, so I'm going to go ahead and just write manganese oxide. So manganese oxide. But what's the charge on the manganese? So I know that the oxide gives me a -2 charge. So I've got 3 times a -2. That gives me a total of -6 as a charge. I've got 2 manganese. So that means that each of those manganese must be contributing half of the charge. So they must be contributing +3 each. So this is manganese 3 oxide. So let's do a few more examples. Let's see if we can get the ion charges. So in our first example, FeCl2. What is the charge on my chloride ion? That's a -1. I've got 2 -1s, so the charge on my iron atom must be that's right, a +2. So we would call this iron 2 chloride. In the next example, the chloride is still a -1. we've got 3 negative ones, so the charge on my iron must be a +3. This would be iron 3 chloride. Our next problem, we have a copper and an oxygen. Now, the charge on my oxide anion is a -2. Since I've got 1 copper, the charge on the copper must be, that's right, +2. Copper 2 oxide. For the next one, we have the oxide again. That's a -2 charge. But this time we have 2 coppers. This means that each copper must be contributing, that's right, +1. So this is copper 1 oxide. And then finally we have chromium and a sulfur. The sulfur is a -2 ion as well. This time we have 3 -2s for a total of -6 charge. The chromium, we have 2 of them. So each chromium must be contributing. Each chromium contributes 3 positive charges. Now going in reverse, this isn't as bad as it might seem, because remember, we're being told the charge on the cation. So our first example, we have cobalt 2 sulfide. So we need to know the ion charge for the anion. The sulfide anion is a -2 charge. That means the cobalt is a +2, the sulfide is a -2. I just need 1 cobalt for 1 sulfur. Now, for tungsten 4 fluoride, all I have to do is, remember, fluoride is a -1 charge. The tungsten's a +4, so how many fluorides do I need in order to use up all that positive charge? I need 4 of them. So tungsten, remember, is W, and then fluorine is F, 4, WF4. Now, for nickel phosphide, the phosphide ion is a -3 charge. The nickel here we have is a +2. So I need to have how many nickels and how many phosphides? So the 2 and the 3, I need to have 3 nickels and 2 phosphides, because my least common multiple of those guys is 6. So I need to make sure that my charges balance. And then finally, we have iron 3 oxide. The oxide is a -2, and here we have an iron 3. Now this is similar to the nickel 2 phosphide in that we just have different ions. The cation is a +3 this time. So we'll have an Fe2O3. And really that's as hard as it gets. Make sure that your ion charges balance. Alright, when we introduce polyatomics, the rules are the same as any other type 2 compound. The only thing is we just change the anion names. So here we have a bunch of examples, and let's start off with the first one. The first one is Hg2Cl2. Hg2 in this case is our polyatomic. This is one of only 3 polyatomic cations. This was named the mercury 1 cation. So mercury 1, and then we name the anion there chloride. So mercury 1 chloride. Next we have cobalt with the dichromate ion, Cr2O7. That Cr2O7 has a -2 charge. So I've got 3 of those -2s. So 3 times -2 is -6. I've got 2 cobalts, so each cobalt must be giving off, that's right, a +3. So this is cobalt 3 dichromate. Cobalt 3 dichromate. Next we have a chromium with CH3COO. This is the acetate ion, which is a -1. I've got 3 -1s and only 1 chromium. So that means the chromium must be carrying a 3 charge. So this is chromium 3 acetate. And then finally, we have Cu2CO3. The CO3 is a 2- charge. That is the carbonate ion. And since I've got 2 coppers, that means that each copper must be contributing only a +1. So this is copper 1 carbonate. And finally, let's practice a few name to formulas. Again, we have to know our anion charges in order to get these right. So the lead-4 sulfate, the sulfate ion is a -2 charge. Since the lead-4 is a +4, so lead is a +4, how many sulfates do I need to have? I need to have 2 sulfates. Remember that the 4 here does not tell me how many leads I have. That tells me the charge on the lead, the charge on the cation, not the number of cations. It likewise does not tell you the number of anions you need. So make sure that you remember that. It is not the number of cations nor the number of anions. It is the charge on the cation. So let's do vanadium-3 hypochlorite. The hypochlorite ion is a -1. So vanadium is a +3. So how many hypochlorite ions do I need? I need 3. So the formula for the hypochlorite ion is ClO, and I need 3 of them. What about gold-3 chromate? The chromate is a -2 ion. So what is my least common multiple of 2 and 3? 6. So I'm going to need 2 golds, so Au2, and 3 chromates, so CrO4 taken 3 times. And finally, titanium-2 phosphate. Phosphate is a -3 ion. Titanium is a +2 ion here. And again, the least common multiple of 2 and 3, we have titanium, we need 3 of those for every 2 phosphates. So Ti3PO4 taken twice. Now that we've gone through these, I highly suggest that you do as many problems as possible. It is the best way to learn your nomenclature is to do problems over and over and over again. Name everything you can.